Morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning,
Good morning, sir.
Any questions from last class? If not, any question? Now, just to wrap up nonlinear programming and how we proceed. So, in general, NLP, whenever you are trying to solve, have a structure, minimize f of x such that inequality constraint and equality constraint. Keep in mind, whenever you have equality constraint, the feasible point has to lie on the optimal point has to lie on the, or local minima has to lie on the equality constraint. Then only it will be satisfied. So to solve such, first write the Lagrangian f of x plus summation j equals to 1 to m. Generally we use mu for non-linear, inequality, and lambda for equality, but it is not hard and fast. It is just at the end of the day, it is a multiplier. You can define whatever you want to define it as. So when you are trying to find a solution, when you look at this equation expression, when you are trying to find a solution, equality constraint, you know, the solution will lie on it. What exactly we are trying to find with the first term or second term? All the active constraints. Okay, the active constraints are ones which has mu greater than 0. That means the constraint is fully satisfied. So that is your Lagrangian. You do del L equals to 0 with all the x's. You add Gjx is less than equal to 0 to check the feasibility. And you also need to check Hix equals to 0. Okay. And complementarity condition mu j into Gjx should be equals to 0. Mu j should be greater than equal to 0 and lambda is unrestricted. Okay, so together they are called KKT conditions, and the point which you get are called KKT points. Okay, and KKT conditions, KKT points, and they give you candidates for local minima. If you can show your Lagrangian is positive semi-definite at the whatever x star and lambda star and mu star you have found, then you can say the local minimum, the point which you are checking at is your global minimum. Is this clear, guys?
Yes, sir.
So this is when you have inequality, equality, all kind of constraints in the problem. This is how you solve a general nonlinear programming, which are we are assuming here that fx, gx, hx all are differentiable. Now, before I get into next topic, which is quadratic programming, which is a special type of nonlinear program, I will just do a quick. Did you guys get a chance to look at the simplex algorithm?
Yes, sir.
So I'll quickly go, maybe for half an hour, I will go over simplex algorithm. So suppose I'm working with a problem, maximize g equals to 3x1 plus 5x2, x1 is less than equal to 4, 2x2 is less than equal to 12, 3x1 plus 2x2 is less than equal to 18, x1 comma x2 greater than equal to 0. Suppose a linear program I'm trying to solve. So how do we solve when we are trying to use simplex algorithm?
So firstly, we introduce slack and surplus variables by making
Let's
equal
let's
different equal.
so x1, let's say I use x3
Yes,
as
sir.
variable for first one. For second one, 2x2 plus x4 equals to 12. Because we have to solve system of equation to find the solution. So we need to make it an equality constraint, right? Is this correct?
So 3x1 plus 2x2 lost constant.
3x1 plus 2x2. Right, guys? So these
Yes,
are
sir.
called our equation 1, 2, and 3. These are the functional constraints which we solve to find the feasible solution. And we at the same time we also convert the objective function into a constraint form by bringing 3x1 and 5x2 equals to 0. Is this right? So if you look at it from a graphical representation point of view, this is your x1 less than equal to 4, so 4 comma 0. This is 2x2 is less than equal to 12, so this is 0 comma 6, and this is your 3x1 plus 2x2. So the feasible region is this portion. Okay, and the points you will get is, if you plug in x1 equals to 4 in this equation, you will get 4 comma 3, and here you will get 2 comma 6. So when you say you are initializing, so the way we initialize simplex table is we put iteration number, basic variable, equation number, G, and then x1, x2, x3, x4, and x5, right? And then RHS. We'll also keep some. So initialize with what are the basic variables to start with?
x3, x4, and x5.
What we do, we since it is a less than equal to, so this is in our standard form. Let me just say that it is a maximization problem. All constraints are less than equal to type, and all the resources, that is b vector, is greater than 0. So it is in our standard form. If you see, whenever you have a maximization problem with less than equal to constraint, 0, 0 will always satisfy. So we can start with x1 and x2 as a non-basic variable, and in that case g, x3, x4, and x5 we will get. Equation 0, 1, 2, 3. This is for the gth equation, the 0th equation which I have written. So we keep it separate, and then rest of the equation we put -3 from 0th equation, -5, 0, 0, 0, and 0. Here 1, 0, 3, 0, 2, 3, 1, 0, 0, 0, 1, 0, 0, 0, 1, and 4, 12, and 18. So it is already in proper Gaussian elimination form, if you can see here. So we can say x3, x4, x5 equals to 4, 12, and 18 respectively, and g equals to your 0. You remember until this point?
Yes, sir.
Now what we do, we look at the most negative number in the 0th equation. That is our objective function. So this is most negative number. So we will make x2 enter the basis. If x2 is entering the basis, someone has to leave the basis. Right now, basic has x3, x4, and x5. So that we generally find using minimum ratio. I should have done it here. I'm showing minimum ratio here. So what we do a pivot column and take the ratio of RHS divided by the strictly positive value in the pivot column. So 4 by 0 is not possible, so we put a dash. Had it been a negative number, we will again put a dash. 12 by 2 is 6, and 18 by 3 is, did I make some mistake? 12 by 2, 18 by 6. Oh, this is 2, sorry. 18 by 2 is 9. So your minimum ratio is 6. So this becomes your pivot row, and we'll make x4 to leave the basis. So in the next iteration, I will have g, x3, x2, and x5. And what we need to do is this now, since x2 will be calculated from this row, so we have to make it 1 here, so that it is in the proper Gaussian elimination form. I hope you know what proper Gaussian elimination form is. Otherwise, just refer after this class. So this equation from x4 is leaving and x2 is entering. So I have replaced x4 with x2 here. So x2 will be calculated from this equation now. So all we need to do is divide it with this is called pivot number, divided the whole row with pivot number. So 0, 1, 0, 1, 0, 12 by 2, 6. Now above this and below this, there should be no one. It should be all zeros, the coefficients. So that you
Sir,
need.
fourth element will be 1 by 2.
I'm sorry?
0, 1, 0, 1 by 2.
1 by 2, sir.
Yeah. So we just need to ensure to put in a proper Gaussian elimination form. Below it and above it, all the coefficients should be 0. Then only it can be called that this equation is for basic variable x2. Okay, and we proceed until we reach the solution. So what you will see in this case, first we started at 0, 0, then we will reach to 0, 6, and then we will reach to 2, 6, which is the optimal solution. And all the coefficients in the 0th equation, when we reach 2, 6, will become greater than equal to 0. And then we say that we have reached the optimality. Is it a quick review? You remember things? Now problem starts. Again writing, this is the standard form which we are using. Maximize g equals to cx, ax is less than equal to b, and x is greater than equal to 0. This is the standard form which we are following. Now, if I change one of the constraint, suppose maximize g equals to 3x1 plus 5x2, x1 is less than equal to 4, 2x2 is less than equal to 12, 3x1 plus 2x2 is less than equals to 18. So the only change I'm doing, I'm making it equals to 18. Okay. So I have changed less than equal to constraint to a equality constraint. What would be the consequence when we try to run the simplex algorithm which we have seen? Now, what happens to the feasible region? So again, I will draw x1 equals to 4, direction is in this direction, 2x2 is less than equal to 12 in this direction, this is 0, 6, this is how much? 4, 0, and then this line which is intersecting at 2, 6 and 4, 3. Now, where is the feasible, feasible region for this problem with equality constraint?
Sir, on the line 3x1 plus 2x2 equal to.
Is he right, Akshat?
Sir, that between those lines, like x1
Yeah,
equal to 4.
I got it, Nicholas. Akshat,
Yes, sir.
is he saying right?
Yes, sir.
Why? Akshat, I believe we were talking to each other. Are you angry at me?
So I agree, but yes, I feel like that.
So why? Because in earlier case, this was the feasible region. Now, what Nicholas is saying, just this much is the feasible region. I mean, the line between these 2 points. Does it look right?
Because, sir, we have an equality sign now equal to 18.
Yeah.
So that makes it a constraint, like the points that is lying on that line will be the only feasible region.
Okay, very good. So all of you realize that now your solution can lie only on this line. Okay, and since simplex works on the corner points only, one of these two will be your optimal solution. You agree?
Yes, sir.
Now, earlier we were able to easily start with 0, 0 as a solution. Can we use 0, 0 as solutions to start this problem? Let's first expand it. So let's say g equals to 3x1 plus 5x2 is my first zeroth equation. x1 plus x3 slack variable equals to 4. 2x2 plus x4 equals to 12 and 3x1 plus 2x2 equals to 18. So how many equations I have and how many variables I have? So I have 4 variables now, x1 to x4, which has to be greater than or equal to 0, where x3 and x4 are slack variables. You agree? And I have 3 equations. Now, how should we initialize this?
Sir, put any one of variable equal to 0 and solve for the remaining 3 variables.
Okay, tell me which variable I should put equals to 0. Your choice.
Yes, sir, any one variable.
Okay.
x4 equal to 0.
x4 equals to 0 कर दिए. Okay, if I put x4 equals to 0, x2 can be calculated from this equation.
Yes, sir.
Right?
x2 will be 6.
X1 and x3 value. Because when we are doing Gauss-Jordan elimination, we have to ensure that each equation uniquely defines the one of the basic variables. Will I be able to initialize our simplex algorithm? Guys, are you able to see the problem here?
Here we generally split the equation.
I cannot hear you. Can you be a little louder, please?
Sir, here we generally split the equation into two inequalities. For example, 3x1 plus 2x2 greater than equal to 18, and then 3x1 plus 2x2 less than equal to 18.
2x2 less than equal to 18 and 3. Actually, you are making it more complicated, but anyway, let's go ahead. 3x1 plus 2x2 greater than equal to 18. Okay, how do we deal with, so again, I will add one more x5 here and make it an equality constraint. How do I make it this as equality constraint?
So I will subtract one x6, and for that one I will need another variable later on.
So minus x6 equals to 18. Is that fine?
So that is fine, but when I am taking the x1 and x2, all of these are 0, then x6 will become negative 18. So to prevent this negative 18, I will need an artificial variable.
So why don't I just add the artificial variable here only? Do you realize? So for equality and greater than equal to, we use artificial variable technique. The importance of artificial variable is to initialize the simplex algorithm, that's all. So in case of greater than equal to, first we subtract a surplus and then add an artificial variable. For equality constraint, we can go ahead and directly add the artificial variable. Does that make sense, Shantanu?
Yes, sir. Yes, sir.
Yes, sir.
Okay. So let me clean this one. What you are saying, Shantanu, this can be done greater than equal to and less than equal to. For that, we have to use dual simplex algorithm. We have to convert it into minus 18 and then proceed. Because dual simplex can work with negative RHS, if you remember. So what we need to do is to initialize. The idea is, see, when we put it in the simplex table, see, each of these basic variables are uniquely defined by this 1, 0, 0 structure, because the rest of them are non-basic variable, x1, x2, everything is 0. So x3 into 1 equals to 4, x4 into 1 equals to 12, and x5 into 1 equals to 18. This is how it works. So each of the equation, uniquely finds the value of one of the basic variable. And that's why to initialize, In this case, I need a artificial variable. Now I can start with 0, 0. But what is the catch? When I start with 0, 0, I start with an infeasible solution. But as I progress, finally I reach to the original problem, and there I solve the. So what I can say, this artificial variable technique, as long as A1 is in your basis, you are, for the original problem, you are solving an infeasible problem. But since I have added A1 here, I'm not solving the original problem. When I reach to this point, or when I reach to this point, artificial variable will leave the basis. It will be not the part of the basis. And we can say that, okay, now I have an initial feasible solution to start the original problem. So you understand why artificial variable techniques are used?
Yes, sir.
So if I add a plus A1 here, and it is an equality constraint, at the solution, what value I expect for A1?
To be 0.
To be 0. So how do I ensure that it is 0?
To penalize in the either in the objective function, or we have to use two-phase method.
Okay, so we generally, I'm just giving you a bigger method example, but I will only discuss two-phase. We can penalize because we are trying to maximize this. If I penalize with minus a very large number m into A1. So whenever A1 tries to take a value, it will be decrease the objective function value. So what A1 value it will prefer? 0?
0, sir.
Yes.
You can say that A1 can be negative, but the way we have defined x1 to x4 and A1 should be greater than equal to 0. So the best value for A1 is 0, and this is how we ensure that. Fine. So there is another variable where we do not need to, this is called Bingham method. There is another method which is also known as two-phase method. Out of this two-phase, we only need a first phase for quadratic programming. So in two-phase method, what we do, let me just write down the maximize g equals to 3x1 plus 5x2, x1 plus slack variable equals to 4, 2x2 plus slack variable equals to 12, and 3x1 plus 2x2 plus a1 equals to 18. x1, x2, s1, s2, a1 greater than equal to 0. So what we do, as I said, the first phase is starting from here and reaching to one of these points. And second phase then tries to solve the original problem. So first phase, what we will do, we will define two optimization algorithm, two optimization problem. One will be minimize g equals to a1. If I am able to minimize g, what is the best value a1 can get? G can get is 0. Okay, such that x1 plus s1 equals to 4, 2x2 plus s2 equals to 12, and 3x1 plus 2x2 plus a1 equals to 18. This is the first phase. Second one is second phase. Here we solve the original problem after the artificial variable has been removed from the basis. Maximize g 3x1 plus 5x2 such that x1 plus everything original, 2x2 plus s2 equals to 12, and 3x1 plus 2x2 equals to 18. x1, x2, s1, s2 greater than. So if you look at this formulation, we do not have a1 here, right? Why we are able to work with this one? Earlier I have said, come on, I need one equation from everything. Why we will be able to start from here in this case?
Sir, because for first phase only we will get like our A will become 0. So
A will become 0. More importantly, if you look it from a graph perspective, what first phase is doing. This is your optimal feasible region. So first phase is only solving, taking you to the first feasible solution or initial feasible solution to the original problem, right? If someone gives me even for this one, see कहाँ गया वो graph? ग्राफ गायब हो गया यहाँ से. For standard problem, it is not ill behaved, everything less than equal to 0. We started with 0, 0, right? Had I given you that 4, 4, 3 is a feasible solution to this problem, would you start at 0, 0 or 4, 3?
4, 3.
4, 3. The same thing is happening here. The first phase is telling you this is the initial solution to start with. Now you understood how two-phase and big M works actually?
Yes, sir.
So having said that, now we can convert, because our standard form to solve simplex is maximization. I'm telling what I use. If you use different method, it is fine as long as it is you are using simplex. So I will convert into a maximization problem that will lead to minus g plus a1 equals to 0 as my zeroth equation, and rest of the equation as it is x1. So let me first solve the first phase, and I'm only going to discuss first phase with you because this is what I need for quadratic programming. Second phase, I mean, as an industrial engineering student, you should know all these things. If you have forgotten, please revise it. So I will convert minimization into maximization by multiplying a minus sign. So maximize is not required. I will just put minus g plus a1 equals to plus a1 equals to 0, and my constraints are x1 plus s1 equals to 4, 2x2 plus s2 equals to 12, and 3x1 plus 2x2 plus a1 equals to 18. This is my equation 0, 1, 2, and 3. Fair enough, guys? Good so far. What we have to do? First, we have to define the first phase equation. We just want to get rid of artificial variable. So it is generally summation of artificial variables. Luckily, we just have one artificial variable. Had there been more artificial variable, it would have been a1 plus a2 plus a3 plus a4, whatever number you want to put. That we are trying to minimize. Since all the a's are greater than equal to 0, sum of that should be equals to 0. Now, when you are trying to solve, you have got the equation. Can we set up our simplex table now? Iteration, basic variable, equation, G, RHS. X1, X2, S1, S2, A1. Can we set up our table? If yes, why? If no, then what we need to do?
Sir, we need to add artificial variable in equation 1 and 2 also. No?
Why do we need equation 1 and 2?
So because we are making these equal to 4 and 12. So we are changing the sign. No?
I have already added a slack variable to make it an equality. Na?
Okay, okay, sir.
We have added a slack variable to make it equality. Last one was already equality. We need a basic variable to initialize. And as I said, had I given you already x1, x2 equals to this much, all this tangent was not required. You could have started from there. But right now, I do not really know where the first feasible solution happens for the original problem. Is that clear, Manish?
Yes, sir. Got it, sir.
Okay. Now, there is an issue. I cannot start initialize my simplex table. What is that issue? Can you tell me? Okay. Let me.
We do not have a canonical form if we put it in the table.
Okay. So what I need to do?
In that case, we need to add artificial variable in equation 1 and 2 as well.
What Deepak? Look at the problem structure clearly. You have added a slack variable to make it an equality, and then you want to add an artificial variable on top of it. Less than equal to, when we were discussing this problem, after adding slack variables, did we add artificial variable?
No, sir.
Slack variables were your initial solution, right? Initial basic variables. Since equality constraint, we cannot add slack or subtract surplus. So we said artificial variable. It's like it is there, but it is not there. It should be 0 at the end, right? But slack variables need not be 0. It can be positive. What is important is when you look at this equation which we have formed, and we have said that x3, x4, x5 are in your basis, right? Are they appearing in the zeroth equation?
No.
No, sir.
If they appear, it will be not in the proper Gaussian elimination form because some numbers will be there in the zeroth equation. So we need to remove basic variable from here because this is my basic variable for equation number 3, the artificial variable. How can we remove it? You guys have covered all this in decision modeling, right? At least most of our MTech boys. And MF boys, I can understand. Some of you must have taken under me 3 years ago. Then also you didn't want to study. Now also you don't want to. Okay, tell me, how do we get rid of, make the coefficient of A1 equals to 0 in the zeroth equation?
So shifting to right hand side.
शिफ्ट करने से गायब थोड़े हो जाता हो तो इसी इक्वेशन में रहेगा ना अक्षर.
Yes, sir.
See, try to understand.
By including M, sir.
Just a second. Each of these equations are uniquely finding the value. So this equation finds the value. This equation finds the value of this. This equation finds the value of this. This equation finds the value of this. But if there are two basic variables in same equation, you cannot uniquely find, right? What does the basis means actually? Basis means that you can put it in a proper Gaussian elimination form. So minus g is simply equals to 0. S1 simply equals to 4. S2 simply equals to 12. A1 simply equals to 18. Because x1 and x2 are non-basic variable, I'm assigning them to equal to 0. Okay. Now,
Sir, by multiplying M in with A1 in Z equation.
तो उससे क्या हुआ? Still there, right? It has a coefficient. Let me show you what is happening. With this, if we proceed, here we will put -1 because we are minimizing. This is how it, if it is 1, it is maximizing 0, 1, 2, 3. Basic variables are G. Right now you have S1, S2 and A1 iteration is 0. Let me initialize it. X1 is 0, X2 is 0, S1 is 0, S2 is 0, 1. RHS is 0, 1, 0, 3, 0, 2, 2, 1, 0, 0, 0, 1, 0, 0, 0, 1. Right now, these three are your basic variables. Look at the structure they follow. By the way, you guys understand basic and non-basic variables, right?
Yes, sir.
Yes.
So basic variables are the one for which we are trying to uniquely find a value. Non-basic variable, before even starting solving, I am allocating it to be equals to 0 or assigning it to be equals to 0. What is the problem you are seeing with the structure below A1 in the column A1?
It is
As
also present in
equation
0 to
0.
yes, sir. Sir, can we do like that, like writing A1 as 18 minus 3x1 minus 2x2?
18 minus 3x1. Why do I need to write that? Starting solution A1 equals to 18, I already know. So tell me, I directly put there equals to 18. Okay,
Yes,
I
sir. Yes.
not get in that much detail. What I will do, you just need to do equation 0 minus equation 3. That will give you minus g minus 3x1 minus 2x2. A1 will cancel off. So what I'm doing, I'm subtracting equation 3 from equation 0. A1 goes away, I get minus 18. I asked you to review a little bit so that I could easily. So this is my equation 0 now. So what we have done, we have just subtracted. See, the whole simplex algorithm, definitely there is an algorithm. As far as solving equation is concerned, it is algebra, it is Gauss-Jordan elimination. We have to put it in a this kind of form. This is like, suppose if I want to calculate the values of by variables x1, x2 and x3 equals to something 2, 13, 14. This is the form I have to put it so that it simply becomes. So now I have subtracted equation 3 from equation 0 to get rid of A1. As a result, minus 3x1 and minus 2. Luckily, if you see, because of that, at least we will be able to enter something into the here. Is this step clear?
Yes.
So now you can look at it. This is in proper Gaussian elimination form. Okay. So which one will enter? Which one will enter the basis?
X1.
Because it has the highest negative coefficient.
Yes.
So x1 will enter. This is my pivot column. My minimum ratio can be obtained as 4 by 1 equals to 4. 12 by 0 not possible. 18 by 3 is 6. So minimum, since minimum is 4, this is my pivot row. I will make this. So which one is leaving the basis? S1 is leaving. S1 will leave the basis. So since x1 is entering the basis and the basis has a length of only 3 because we have 3 equations, someone has to leave. So S1 will leave the basis. So iteration basic variable equation G x1, x2, S1, S2, A1, RHS. So iteration 1 G. Now in place of S1, we will have X1 because X1 is entering the basis. S2 or A1 remains the same. They are being calculated from the same equations. Minus 1, 0, 0. Now, it is already 1. So I don't need to do, the pivot number, I have to make it 1. So the coefficient becomes 1. So I will copy it is as it is 1, 0, 1, 0, 0 equals to 4. Now, this I need to make this as 0. This is already 0 and this as 0. So if I multiply this equation with 3 and add it to the first 0th equation, I will get rid of minus 3. So 0, minus 2, 1 into 3 plus 0. No. 1 into 3 is 3. 3 into 0, S2 was 0, it remains 0, A1 remains 0, RHS is 4 into 3 is 12. I made a mistake, it should be minus 18 actually, minus 18. Minus 18 plus 12 is minus 6. Below it already 0 is there, so I do not need to do anything, just keep it as it is. But this one is 3. Again, you need to multiply this with 3 and subtract from this equation. You will get 3, 2, 0, 0, 1, and 6. Okay. This one is 0. Hold on, I made a mistake. This will become 0. 0, 2, sorry, minus 3. Minus 3, 0, 1, 6. So you understood what exactly I have done here? Since x1 was entering the basic variable, so below it and above it, everything needs to be done 0. So all the row operations we have done to make everything above and below it as 0, and rest now I can say x1 equals to 4, s2 equals to 12, and a1 equals to 6. Sorry, minus 6. Minus 18. Clear so far? Any questions? Is it clear, guys, what we have done?
Yes.
Okay. Do the next iteration. If it is clear, do the next iteration. See which one will enter, which one will leave the basis, and see whether you have reached optimality or what. I give you, chalo, I give you complete 10 minutes to figure that out. Okay, just for you to initialize, which one will enter the basis now?
Sir, x2.
X2, because that is the most negative coefficient or the only negative coefficient. So X2 will enter. Now, if X2 will enter, we have to calculate the minimum ratio. Minimum ratio. So 4 by 0 is not possible. 12 by 2 is 6 and 6 by 2 is 3. Which one will leave the basis based on the minimum ratio?
A1.
A1 will leave the basis. That is the most satisfying moment when your artificial variable leaves the basis. You are reaching to the first initial solution of the second phase. So A1 will leave the basis, X2 will enter the basis. So G, X1, S2 and X2, 0, 1, 2, 3, minus 1, 0, 0. Put everything in the Gaussian elimination form. Give me the value of X1, X2 and S2.
Sir, I have one question.
Yes.
Sir, why we have added this extra equation minus z plus a1 equals to 0?
Which one?
Sir, in above where we are solving the first phase, here we have written minus z plus a1 equal to 0. If we don't write that, even then if we are trying to minimize a1, we'll get 0, no? a1 minimize. If we are trying to minimize a1, then we'll get a1 0 by solving equation 1, 2 and 3. So why we have added this equation 0?
I'm sorry, I'm not getting it.
So we are in the first phase, we are trying to minimize a1 so that we get our initial solution and we get a1 equals to 0.
Okay.
So sir, why do we need this extra equation, 0th equation, why we have written? Sir, I'm asking that.
Okay, that is a normal nomenclature. Okay. The simplex, had it been some other, like, because what if I do not keep this equation, when I will plug in these numbers, I need the 0th equation. For this one, you need the 0th equation or not?
Sir, for what?
when first phase is completed, second phase you have to start, whether that.
Yes.
Okay, let me just look at the normal simplex then. In this case, you needed the zeroth equation or not? Or here also you say that it is not required?
Sir, even there, sir, basically,
Sir, way we have learned, we used to write it above.
yes, sir, we used to
You
write
write it above or below, Kishan, doesn't matter. It is Gj minus Cj or Cj minus Gj.
Right, sir.
Okay.
Yes, sir.
You may have learned different nomenclature. The simplex algorithm remains same because that is the equation that will decide which one will enter.
Yes, sir. That's why I got
Yes, sir.
confused.
Okay, it is as simple as that. And here, that's why I need that equation. You can put it above or below. Everybody follows their own nomenclature. You are free to use your nomenclature. As far as I said, simplex remains the same.
Yes, I understood.
Okay.
Yes, sir.
So what I need is, I do not care which nomenclature you have learned and which nomenclature you follow. I need the value of your basic variables and gth or the objective function value g in every iteration. That's all I care.
Yes, I understood.
You can use revised simplex to solve it. You can use algebraic simplex to solve it. Doesn't matter to me.
Yes, sir. Yes.
Okay, guys, complete this iteration. I think by 10:56 you will be able to complete. We'll meet at 11:05. Okay. We'll again assemble at 11:05. Try to solve it by then and take a 10 minutes break after that. Thank you, guys. Okay, guys, are you back? So what did you get? So you must get 0, 1, 0, 0, 0, 0, 0, 1, 1, 1, 3 minus 3 by 2, 0, 0, 1, 0, 0, 4, 12, and sorry. 0, minus 1 and 1 by 2. Right hand side you will get 0, 4, 12 and 3. Did you get this?
Plus 63, 0463.
Sir, in the initial that Z1, S1 is 1013 minus 3 by 2, sir?
Which one?
Sir, under the S1, that
S1
one,
or S2?
that column is that
1, 3,
113 that you have written, 1133 minus 3 by 2. So 013 minus 3 by 2 it would be, sir. I'm not.
Is S1 a basic variable?
Under the S1, sir. Yes, sir.
Yeah. Under the S1, this one, na?
Yes, sir. 013 minus 3 by 2 it would be, sir.
This coming
Am
0?
I right? Yes, sir. I'm
Yes, sir.
not right, but
013 minus 3 by 2.
okay. Yes, sir. Yes. It would be 013 minus 3 by 2.
Yeah, right. Actually, it is 3 now. Yeah, 013 minus 2. So although it is a non-basic variable, this also tells us something, which is that there are multiple optimal solutions. But let's not worry about that. So you have reached the optimality. Everything is greater than or equal to 0. Your objective function value is 0. A1 has left the basis. There could be instances where A1 will be in the basis, but its value is 0. Then also the objective function value will become 0, because if you look at your objective function, it is minus g equals to minus A1. So it is actually equals to 0. So what solution you have got? X1, X2, S1, S2, A1 as 4, 3, 12, 0 and 0. Is this correct? Let's look at graphically what has happened. Zero, 0, 4, 0, 0, 6, 4, 3 and 2, 6. And this was your feasible region. Sorry, this color is not good. This is your feasible region. So let's start from iteration 0. Your S1, S2 and A1 were 4, 12 and 18. That means you started at 0, 0. Then you move to X1 equals to 4, X2 equals to 0. This point. And then you move to 4 and 3. Now see, this is a feasible point for original problem or not? Is it a feasible corner point for original problem or not?
Yes, sir.
So this is where we will invoke second phase. So the artificial variable techniques helps us in reaching to the initial solution. So from here onwards, we will solve the problem. We may get 2, 6 or 4, 3 itself is an optimal solution that you need to check in after you plug in the actual objective function value by dropping the column for A1. But we need only until here for quadratic programming. So I'm not getting into details of second phase. So let's come to quadratic programming. So this is a special class of nonlinear programming which has a structure maximize G equals to Cx plus X transpose dx. A of X is less than equal to B and X is greater than equal to 0. So what it has? Quadratic objective function less than equal to constraint, less than equal to linear constraint. If it is non-linear, you cannot solve it as a quadratic programming. Less than equal to linear constraints or linear functional constraint to be precise, because these are the points which are irresponsible for finding a solution, and non-negativity constraint. If any problem when you are trying to solve a non-linear programming problem, if any problem, if it follows this structure, we say that it is a quadratic programming problem, and there is a way to use the first phase of the two-phase problem solution and find the solution. So for example, minimize x1 square plus 3 by 2 x2 square minus x1 minus x2 such that I keep forgetting x1 plus x2 is greater than equal to 6 and x1 comma x2 is greater than equal to 0. Let's see whether it falls under this or not. So for that we need to write our C, D and A. So look at this problem and tell me, first of all, let me first convert it into a standard form, which is of this form. Maximize minus x1 square minus 3 by 2. I'm just multiplying it with a minus to make it a x1 plus x2. Minus x1 minus x2 is less than equal to minus 6 and minus x1 is less than equal. No, x1 x2 is fine. x1 x2 is greater than equal to. So now I have put it in the standard form for quadratic programming. So can you tell me what is C vector, what is D matrix and what is A vector for the problem which I have written in the top? C, A, D and A matrix and vectors.
Sir, C will be 1, 1.
C will be 1, 1. D will be minus 1, 0. 0 minus 3 by 2.
Yes, sir.
And A will be your minus 1.
Minus 1, minus 1.
So this is in a quadratic programming. So had you been given this problem, how would you proceed? Let me write the problem. Maximize x1 plus x2 minus x1 square minus 3 by 2 x2 square minus x1 minus x2 is less than equal to minus 6 and minus x1 is less than equal to 0 minus x2 is less than equal to 0. Is this fine, guys? Can we write now KKT conditions for this problem? So my Lagrangian becomes x1 plus x2 minus x1 square minus 3 by 2 x2 square. Okay, one thing, for functional constraint I will use lambda. For functional constraint I will use lambda as my multiplier, and for non-negativity constraint I will use mu, just to distinguish between which one is my functional and which one is my so lambda into 1 minus x1 minus x2 plus 6 minus mu1 x1 minus mu2 x2. See if it is fine, if our Lagrangian is fine. Because for
Sir, do we need to include non-negativity constraints in Lagrangian?
yes. If you remember KKT condition, in the last problem we have solved, we have taken x and y as as a constraint. When we write KKT condition, we need x1 and x2. When we work with simplex, it is fine. You can say x1, x2 greater than equal to 0 and we leave there. Is that okay?
Yes, sir.
Now, Give me del L by del X1 equals to how much it is?
One minus 2x1 minus lambda minus mu1.
How much?
1 minus 2x1 minus
Hmm.
lambda minus mu1.
2x1 plus lambda plus mu1 equals to 1. Is this correct? Just check.
Yes, sir.
Del L by del X2. Similarly, you will get 3x2 plus lambda plus mu2 equals to 1. Fine.
Yes, sir.
Yes, sir.
Now I need to write my other minus x1 minus x2 should be less than equal to minus 6. Lambda into 6 minus x1 minus x2 is equal to 0. Mu1 x1 equals to 0 and mu2 x2 equals to 0. And I'm putting here lambda, mu's and x are greater than equal to 0. Is this fine?
Yes, sir.
Now do one thing. By adding slack, make it also an equality constraint. So if you look at these three constraints, the first three constraints, 2x1 plus lambda plus mu1 equals to 1, 3x2 plus lambda plus mu2 equals to 1, minus x1 minus x2 plus s equals to minus 6. And let me write other constraint here. I'm replacing 6 minus x1 minus x2 with s because I have added this s here. So lambda into s equals to 0, mu1 into x1 equals to 0, and mu2 into x2 equals to 0. Look at these three constraints and these three constraints. What are the nature of these two sets? What are the nature of these two sets you are looking at?
Here one equal to 0 and one not equal to 0.
This is linear and this is non-linear.
Okay.
Why? Because x, lambda, mu1, mu2, everything is decision variable. When two decision variables are multiplied, it is no more linear constraint. You agree?
Yes, sir.
Now, interesting thing is, as far as solving these equation is concerned, we can use first phase of simplex algorithm. But how do I ensure this is being satisfied? So what I have, three equality constraint I have, and 3 equality but non-linear constraints are there. How do I ensure that I try to solve the system of equations while ensuring that this will happen? So there is a way. Let's first convert this into a equality constraint. So I need artificial variables. So 2x1 plus lambda plus mu1 plus a1 equals to 1, 3x2 plus lambda plus mu2 plus a2 equals to 1, and let me convert into equality x1 plus x2 minus s plus a3 equals to 6. Is this correct? Just have a look. I multiplied this equation with minus and then added a artificial variable. Good so far? And of
Yes,
course,
sir.
x1, x2, lambda, mu1, mu2, a1, a2, a3, all greater than equal to 0. Here we can invoke the first phase by saying that I want to minimize G equals to A1 plus A2 plus A3 and set up the, so let me convert into our standard for maximization. So maximize G equals to minus A1 minus A2 minus A3, which gives me an equation G plus minus G plus A1 plus A2 plus A3 equals to 0. This is my equation 0. And my other equations are as it is, 2x1 plus lambda plus mu plus A1 equals to 1, 3x2 plus lambda plus mu2 plus A2 equals to 1, and x1 plus x2 minus s plus A3 equals to 6. Just look at it. If you feel any, if you have any doubt, please go ahead. So what we are trying to do, we are trying to solve this system of equation. This system equation requires A1, A2 and A3 equals to how much?
0.
0. And since A1, A2, A3 are greater than or equal to 0, that means individually they should be equals to 0. The moment I find A1, A2 and A3 equals to 0, I can find the values of other variables that are important to me. Again, to invoke simplex, I need to get rid of A1, A2, A3. This is my initial solution I'm starting with. You agree? So what we need to do? Since A1, A2, A3 I'm initializing with my simplex algorithm, they need to be removed from, their coefficient needs to be removed from the zeroth equation. So equation 0 minus 1 minus 2 minus 3. That will give me the final equation 0. So just do this equation 0 minus 1 minus 2 minus 3. Tell me what you get. What did you get, guys? It's not time. Minus G. Okay. 2x1 plus x1 here minus 3x1. 3x2 plus x2 here minus 4x2. Lambda plus lambda minus 2 lambda minus mu1 minus mu2 plus s equals to 1 plus 1 2 plus 6 minus 8. Did you get this?
Yes, sir.
Now set up your simplex table and try to solve. But so far I have not discussed what to do with these three. Lambda into s. S is nothing but minus 6 plus x1 x2. Lambda into lambda into s equals to 0, mu1 into x1 equals to 0, and mu2 into x2 equals to 0. Now suppose when I'm doing my iterations, basic variable g, a1, a2, a3, g minus 1, it is a minimization, so minus 1, and then x1, x2, lambda, mu1, mu2, s, a1, a2, a3. Lambda into s equals to 0, mu1 x1 equals to 0, mu2 x2 equals to 0, and RHS. So we will initialize minus 3, minus 4, minus 2, minus 1, minus 1, 1, 0, 0, 0, right hand side, minus 8. Rest of the values are 2, 0, 1, 0, 3, 1, minus 1, sorry, plus 1, 0. This eraser, seems like my pencil is now dying. 1, 1, 0, below mu1, 1, 0, 0, below mu2, 0, 1, 0, below S, 0, 0, 1. A1, A2, A3 is in our proper Gaussian elimination from 1, 1, 6. Is this correct, guys? Just check it with the equations and okay.
In the equation under S, it is -1.
Which one?
Third equation for A3. Under S, it is -1. Means x1 plus x2 minus S plus A3.
Oh, yes, right. -1. Okay. So which one will enter the basis? Of course, -4, the highest negative value. Let's try to take the minimum ratio. So 1 by 0 is not possible. 3 by 1. 3 by 1. Sorry, 1 by 3 is 1 by 3. And 6 by 1 is 6. So minimum ratio is, so A2 will leave the basis. Okay, A2 will leave and X2 will enter the basis. So G A1 instead of A2, now I have X2, A3, -1, 0, 0, 0. So this equation I have to first make the pivots number as 1. So I divide the whole equation, this equation by 3, so that it becomes 1. So 0, 1, 1 by 3, 0, 1 by 3, 0, 0, 1 by 3, 0, 1 by 3. Fine, guys. Now I need to get -4 here. So multiply this equation with 4 and add it to the first equation. So multiply this equation 2 with 4 and add it to first equation. So I will just write it here. Into 2 and add it to equation 4. So what do you get? Tell me. -3, right? Because 0 into 4, -3 plus 0, nothing is changing. -4 and +4 become 0. Here is -2 and I'm adding +4 by 2 to S. So -2 plus 4 by 3. Is this correct? So -6 plus 4 is -2 by 3. Okay, so how much we get? -2 by 3 here. This remains -1. -1 plus 4 by 3. So 1 by 3. This remains 1. This remains 0 into 4, 0. This becomes 4 by 3. And A3 becomes 0 into 4, 0. And -8 plus 4 by 3. -20 by 3. Is this right, guys?
Yes, sir.
Give me for A1 and A3 and then I will tell you the next step. What do you get for A1 row and A3 row? You just need to ensure that there is a 0 here and there is a 0 here. These two you need to ensure. Give me all the other numbers. Also, since A1 and A2 are in the basic variable. So you can put all these equals to 0. And now give me what are the numbers you get.
Sir, up to that, can you just repeat the part CDA, how you just valued?
What is that?
Sir, the upper part, sir. The CDA values, sir. Sir, can you just scroll up?
Yeah.
That value, the C and D and it, how can you write this?
You look at the standard form, look at your equation, tell me what should be the CDA. Your standard form is maximize J equals to Cx, G equals to Cx, Ax is less than equal to B, X less than equal to 0, right? So this
Yes,
problem
sir.
was minimized. So first I put it in the standard form and now I just compare the matrices. So C is what? C into X. This is X transpose dx. You understand what X transpose dx will give you. This will give you the square term, right?
Yes, sir.
Now you got it?
Sir, the part D, you write it in the form of matrix, like that I not got.
What does X transpose dx means? X1, X2, minus 1, 0, 0, minus 3 by 2, and then X1, X2, right?
Yes, sir. Got it, sir. Got it.
So when you trying to get a square term, it cannot be vector directly, right? So this
Yes,
is
sir.
1 cross 2, this is 2 cross 2, and this is 2 cross 1. So 1 cross 2 into 2 cross 2 will give you what? 1 cross 2, and then 2 cross 1. 1 cross 2 into 2 cross 1 will give you 1 cross 1. That is your x1 minus x1 square into minus 3 by 2x square.
Okay,
Fine.
sir. Got it. Thank you, sir. Yes.
Yeah. So now try to get these numbers. Sukur, are you here? I've been trying to talk to you since yesterday. Sukur Mahmood. Sukur Mahmood, can you hear me?
Sir, for A1 it is
Just
10.
1 second. Just 1 second. Trying to have some fun today. 8876273540.
आप सबके साथ और सबके प्रयास से भारत ने 150 करोड़ कोविड टीकाकरण की बेमिसाल उपलब्धि हासिल की है। अपना टीकाकरण अवश्य पूर्ण करें और कोविड अनुरूप व्यवहार का पालन करते रहें।
Sukur, are you here? Okay, Sukur decided not to pick up my call.
Hello, sir.
Yes, Sukur, where are you, man? I have been trying to talk to you since yesterday.
Sir, actually, my health is annoying.
So, how many people are with you in your room right now?
Sir, I'm alone.
So, are you trying to attend these lectures, or just you are just for attendance sake you are here?
Sir, from last 2-3 days, I'm feeling not well.
So, are you attending today's class?
No.
Huh?
Actually, I'm trying to concentrate on class, but I'm not able to concentrate.
So, why don't you ask me questions when you are facing any problem, Sukur? If you are not able to understand something, so have you heard to today's class what we are discussing?
Sir, actually, I'm facing health issues.
Huh?
Health issues, sir.
But you are attending class. I can see you were here yesterday also. So if you are facing any problem, you should inform me, right?
Yes, sir. Yes.
Okay. It's your wish if you want to learn. Otherwise, how much I can trace you, buddy. Okay. Yes. Tell me, what is the A1 equation coefficients, guys? Okay, Sugar, you can mute yourself. Thank you. Yeah, someone was telling me the numbers. Please go ahead.
Sir, 1 0 1 by 2 1 by 2.
Just
0
0 1 0 1 by 2
1 by 2
1 by 2
0 0 1 by 2
0
1 by
0 0 1 by 2 and
Sir, only 2 0, sir. Only 2, then after 1 by 2.
okay. I'm just going back to until 1 by 2 and then give me the numbers.
0 0
0 1 by 2. Just go ahead.
And then 0 0 1 by 2.
So let me see. This was the equation. I multiplied how much? It got up. It was already 0 above this. Why did you make any changes in this equation?
Sir, it will be same, sir. 2 0 1 1 0 0 1 0 0.
Yes, sir. Same, sir.
Gaurav, I think there is some misunderstanding. You understand? It's already 0 here. It's already 0 here, right?
Yes, sir.
Then you don't need to do anything with that equation. You just copy it as it is. 2 0 1 1 0 0 1 0 0 1. Did you understand?
Yes, sir. I just did some mistakes. Sorry.
Okay. What is the last line you have got for A3? Anyone?
Sir, 1 0 minus 1 by 3. 0 minus 1 by 3. Minus 1 0. Minus 1 by 3.
And
1.
1. Good. And the value you have got is?
That will be
17 by 3.
17 by 3.
17 by 3.
Now here, which one will enter? The basis. So when you decide which one will enter that basis, you have to keep this one in mind. What do I mean by that? Let me tell you. Suppose it is minus 3 here, but suppose x2 was multiplied with mu2. So if I allow mu2 to enter, for some reason mu2 was a very high negative number, I will not allow mu2 to enter. Why I will not allow mu2 to enter?
Because x2 is already in the basic, mu2
Very good.
x2 equal to 0 means one will be in basic, another will be in non-basic.
Very good, very good. So the way we check these conditions are when we allow someone to enter the basis, we check these numbers. Check this one. If lambda is in the basis, S cannot enter. S cannot enter means lambda is a basic variable, S is a non-basic variable, it automatically becomes 0. Similarly with mu1, x1, mu2, x2 and so on. So this is how so far we have not faced any of these equations are not being violated so far. Even luckily -3, that means x1 will enter the basis now. X1 will enter the basis now, so we do not need to worry about that also. So again, make it as a pivot column, try to get the, so 1/2, 0 is not possible, 17/3. So which one is the minimum ratio? Which one is the minimum ratio? 1/2? Now A1 will leave the basis. So A1 will leave the basis. So your new basic variables are G, X1, X2, A3, -1, 0, 0, 0. And then you proceed with the same thing. Go ahead, do this iteration. Complete this iteration and see what happens.
Sir, in the above table, the value just beside x2 should be -4, right?
Value just beside x2. Just tell me, I'm pointing there. Here?
Sir, the left one.
This one? Sorry, left one. Can you just tell me the column number? X1,
First column.
First column X1. And which row?
Sir, actually not that one, sir. Z, the column Z.
Column Z.
And the last one, last X2 where you have written.
What it should be?
So basically, this column Z is the coefficient of A1, A2 or A3 in the objective function.
Column Z, you are talking about column, right?
Yes, sir.
Column, this is just basic variables. What are your basic variables at that particular iteration?
Yes, sir. Sir, means the values that like after A1, A2 and A3, just after that column, you have written 0, 0, 0. So this 0, 0, 0 indicates the value of that those basic variables, the coefficient of those basic variables in the objective function. So similarly, in the next iteration also, when A1, X2 and A3 is there, so it should be 0 and then coefficient of X2, which is -4, and then again 0.
These are just that the G variable, it is not present in any other equation. That's all it is saying. In the zeroth equation, G variable, G as a basic variable has a coefficient of -1. Rest of the equation, it has a coefficient of 0. This is all it is saying. This is just a representation of simplex table. This is what you are asking?
Yes, sir. Yes, sir.
It has nothing to do with solving. It is just a representation. What is happening? These X1, X2, X3 you are writing. This G into -1 is giving you from the zeroth equation. Rest of the equations does not carry a G variable. That's why its coefficients are 0. Does that make sense?
So actually I did not understand it exactly.
What is the column name?
Yes, sir, that Z.
So if I'm looking at Z, I'm saying it has a coefficient of -1 in the zeroth equation. Everywhere else, its coefficient is 0. What you are not understanding in this? Let me show the equation.
Okay, sir, I understood now.
Here it has an equation -1 coefficient. Rest of the places it has a 0 expression. So this anyway does not come in your calculation. So you focus on the calculation for time being. As I said, you can use any nomenclature you have followed. I do not have any problem with this. But the people who do not remember or anything, they can follow the nomenclature which I follow. Okay, anyone has a complete table?
Yes, sir.
Okay, go ahead. Let's start with zeroth equation. Just tell me the, I think it's better to tell me the column wise. So X1.
0, 1, 0, 0.
Similarly, 0, 0, 1, 0.
0. 5 by 6.
Lambda is 5 by 6.
1 by 2.
1 by 2.
1 by 3.
1 by 3.
Minus 5 by 6.
Minus 5 by 6. Okay, next.
1 by 2, 1 by 2. 0 minus 1 by 2.
Okay, mu2.
1 by 3, 0. 1 by 3 minus 1 by 3.
Okay. S.
1, 0, 0. Minus 1.
Okay.
3 by 2, 1 by 2.
3
0
by
minus 1 by 2.
3
3 by 2 by 2.
Just a second. 3 by 2.
1 by 2.
Hold on. Pencil is stuck again. 1. 1. My pencil is not working. 1 by 2. Then
0 minus 1 by 2.
0 minus 1 by 2. Next.
4 by 3, 0.
1 by 3, 0.
4 by 3, sir.
4 by 3, 0.
1 by 3 minus 1 by 3.
1 by 3 minus 1 by 3. Last one.
0, 0, 0, 1.
Something looks wrong. I should have at least one negative variable. Anyway, what is your right hand side?
Sir, right hand side I was calculating.
Okay, did anyone, all of you have got these numbers?
Yes, sir. Yes, sir, right.
I should have at least one negative number because I have not reached the optimality. One by 2, 1 by 3. So I'm working with this guy. Huh? Next one has entered here. So 1, 0, 1 by 2, 1 by 2. Now 1 into 2. 1 into 3. So minus 2 by 3. Plus minus 2 by 3. 3 by 2. Very positive. 3 by 2. 3 by 2. Something gone wrong in calculation somewhere. Because what is happening, there are no negative coefficients, right? So ideally, as per this, so we have somewhere made a mistake in formulating or writing the equation. Anyway, I will look into it and I will upload I will solve it. I will just go through it if we have made some mistakes in setting up the equations, because ideally I should have got one negative number. It should have entered so that A3 could have been kicked out. Since A3 is still in the basis, so kahin equation wrong ho gaya. Anyway, I will look at it and let you know by next class. But anyway, you understood what only the important thing is, suppose if I had two choices here to enter, I'm just giving a hypothetical example. Since x1 and x2 are here, mu1 and mu2 cannot enter. So we were only left with the option of lambda to enter the basis. So this is how we check which one will enter and ensure that the non-linear part is being taken care of. As far as this, because I have not solved this problem, I started solving with you guys. So seems some mistakes has happened, but I will check and rectify it. Don't worry, and I will upload it before your class next class. Okay, so you understood how quadratic programming works. A quadratic program will be given to you. You have to write the KKT conditions and then take out the linear equations, add artificial variable and start solving it as your what do you call simplex algorithm, first phase of the two-phase method, while ensuring that if lambda is in the basis, s cannot enter, or if s is in the basis, lambda cannot enter while entering the basic variable. So you just need to add that rule for each of these constraints, and that takes care of your solution. Okay, any question other than this calculation I need to check, and I will get back to you. Other than that, any questions, guys? Oh, I realized my mistake. For KKT condition, this is not my standard form. My standard form is minimize f of x and then g of x should be less than equal to 0. I did all gx less than equal to 0, but I used maximize. You see the problem, guys? For KKT condition which we have used, this was our standard form, right? Are you guys with me? This is our standard for KKT problem. I have used gx less than equal to 0, but rather than using minimize, I use the maximize thing here. And that is why the coefficients get messed up. So do one thing, use L equals to x1 square plus 3 by 2 x2 square minus x1 minus x2 plus lambda minus x1 minus x2 plus 6 minus mu1 x1 and minus mu2 x2. Everything else remains the same, the way we have proceeded. Proceed with this one. I will also upload a solution with this one. You will see that there will be a competition at this stage. Two of them will be trying to enter, but based on the non-linear equations, we will decide which one will enter. Is that okay? You understood my mistake, where I have committed the mistake, and that's why I'm not able to find a value to enter here. Yes, no.
Yes, sir.
Yes, sir.
I should have put in minimize fx form. I proceeded with maximize one, and that's why the coefficient got messed up. So you proceed with this L. You proceed with, let me check with it. Yeah, you proceed with this L and everything else remains the same. You see if you can find a solution. If you cannot, I will upload it. Let me know it by tomorrow evening. Okay, if you have any questions, we can discuss. So here I'm completing the the optimization theory for differentiable functions. Now we'll start looking at the algorithms to solve nonlinear program, and we'll look at the numerical methods from here onwards. That I will start on Thursday. Thank you very much, guys. See you on Thursday. Bye bye.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Let me upload this
sir.
momentarily. Once I will correct it, I will. यार हो क्या रहा है, मेरे को अपलोड भी नहीं करने दे रहा. Save a copy.